Complete darkness, absolute silence, nothing visible. Then, a single heartbeat, slow, steady, human. A faint point of light appears in the darkness. One star, then another, then thousands. The darkness slowly transforms into a breathtaking night sky filled with stars. The camera moves slowly upward, as if a human observer is looking into the universe for the first time. The scene should feel mysterious, emotional, quiet, and deeply cinematic. Do not show aliens, do not show spaceships, do not show futuristic technology yet. Only the night sky. Then transition into a cinematic visualization of the early Earth. Young oceans, volcanic land, lightning crossing a dark atmosphere, a young planet surrounded by a thick atmosphere. Show a microscopic world. Tiny organisms moving through ancient water, life beginning and slowly changing, time accelerates. Simple organisms become more complex, life spreads through ancient oceans, forests rise across continents, ancient animals move through prehistoric landscapes, dinosaurs walk beneath an ancient sky, the camera moves slowly through this prehistoric world, then a massive asteroid approaches Earth. The impact is shown from a distant cinematic perspective. Fire spreads across the surface, dust rises into the atmosphere, the sky becomes dark, the world changes. Do not make the scene unnecessarily violent or graphic. Time accelerates again, the planet slowly changes, mammals appear, primates appear, eventually early humans appear. Then modern humans, a human stands alone beneath the night sky, they slowly look upward, the camera moves toward their face, closer, closer. The stars become visible in their eyes. The reflection of the Milky Way appears in one human eye. Hold the shot, silence. The camera slowly pulls away. The human becomes smaller. The night sky becomes larger. The Milky Way stretches across the entire frame. Narration: for as long as humans have been able to look into the night sky, we have wondered what might be looking back. Pause. Are we alone? The camera continues pulling away. The person becomes a tiny figure beneath the stars. The Earth appears, then the Moon, then the solar system. The camera continues moving outward. The Sun becomes smaller. The planets become tiny points. The solar system becomes almost invisible. The Milky Way appears in full. The camera continues pulling backward. Distant galaxies begin appearing, then more, then more. The observable universe becomes increasingly vast. The screen fills with galaxies. Narration: today, astronomers know that the universe contains an extraordinary number of galaxies. Show a scientific visualization of the large-scale structure of the universe. Do not make the galaxies look like random colorful clouds. Use realistic astronomical colors and physically plausible structures. Narration: some estimates based on deep observations and models have suggested that the number of galaxies in the observable universe could approach 2 trillion. Display the number carefully as an estimate. Potentially up to around 2 trillion galaxies. The number should appear briefly and then disappear. Do not make it look like an exact measured number. Narration: and many galaxies contain hundreds of billions of stars. Show several galaxies. Zoom into one galaxy. Stars appear across its spiral arms. Zoom into one star. Then another. Then another. Planets appear around distant stars. Show rocky planets. Show ocean worlds. Show frozen planets. Show planets with thick atmospheres. Do not imply that these planets definitely contain life. Narration: so somewhere among all of that, could life have appeared somewhere else? Pause. The camera moves toward a distant planet. The planet is dark on one side. Its night side contains a very subtle pattern of artificial lights. Do not show aliens. Do not show flying saucers. Do not show humanoid creatures. The suggestion of intelligence should come only from subtle technological activity. Narration: perhaps another civilization is looking at its own sky, asking the same question. The distant planet slowly disappears into darkness. Silence. Narration: but here is where the story becomes much stranger. Hard cut to black. Silence. A low, deep atmospheric sound begins. Narration: the universe may contain other civilizations and physics may still make contact extraordinarily difficult. Pause. Not because the universe is empty, pause, but because the universe is enormous. Hard cut to the cosmic web, millions of galaxies, billions of galaxies, countless stars. The Earth appears as an almost invisible point. Narration. The universe did not need to build a literal prison around us. Pause. It only needed to obey its own laws. The camera slowly moves toward Earth. Then the screen fades into darkness. Title appears, The Cosmic Prison. The title should be simple, elegant, white text against deep space. No dramatic red text. No cheap effects, no excessive animation. The title fades away. The camera transitions into a dark room. A person stands alone inside. There are no visible doors. There are no windows, but the walls are transparent. Beyond the walls are distant stars. The person looks toward the stars. Narration. Imagine living in a room where you can see the outside, but the distance between you and everything beyond the walls is impossible to overcome. The camera slowly moves toward the transparent wall. The wall dissolves. The room disappears. The camera suddenly enters the Milky Way. Stars surround the viewer. The galaxy stretches across enormous distances. Narration. That idea is not a literal description of the universe. Pause. But it is a powerful way to understand one of the deepest problems facing any civilization that wants to explore the cosmos. The camera moves toward the solar system. Earth appears. Narration. Distance. The screen becomes filled with stars. The camera leaves Earth at extreme speed. The moon becomes smaller. The planets disappear behind the camera. The sun becomes a bright point. The solar system becomes tiny. Narration. Our nearest neighboring star system is more than 4 light-years away. Display. Proxima Centauri approximately equals 4.24 light-years. The text should be simple and scientific. A beam of light travels from Earth toward the distant star. Narration. A light-year is not a unit of time. Pause. It is a unit of distance. The beam continues traveling. Narration. Light itself needs more than 4 years to cross that gap. Show the beam traveling through space. Then introduce a realistic, futuristic spacecraft. The spacecraft should look scientifically plausible. Avoid fantasy designs. Avoid enormous glowing engines. Avoid impossible shapes. The spacecraft begins accelerating. 10% of the speed of light, 30%, 50%, 70%, 90%, the star still looks distant. Narration. Even at enormous speeds, the distance remains vast. Show the spacecraft moving through empty interstellar space. Stars remain scattered around it. Narration. Our fastest spacecraft are nowhere near the speed of light. Show Voyager 1 as a simple scientific reference. Display. Voyager 1 approximately 17 kilometers per second relative to the Sun. Narration. At roughly that speed, reaching our nearest star would take tens of thousands of years. The spacecraft continues. The destination remains incredibly distant. Narration. And the Milky Way is roughly 100,000 light-years across. The entire galaxy appears. The camera slowly travels across its enormous diameter. Narration. So even if another civilization existed somewhere else in our galaxy, the distance between us could still be enormous. Pause. Camera pulls farther backward. The Milky Way becomes one galaxy among many. Andromeda appears. Display. Andromeda approximately equals 2.5 million light-years. Narration. And our nearest large neighboring galaxy, Andromeda, is about 2.5 million light-years away. The camera continues pulling back. Narration. The universe is not simply big. Pause. It is big on a scale our everyday intuition was never designed to understand. Silence. The camera moves toward another wall. This wall is not physical. It is represented by the structure of space-time. A spacecraft approaches the speed of light. The spacecraft accelerates 90%, 99%, 99.9%, 99.99%, 99.999%. The numbers continue increasing, but never reach 100%. Narration. Then we encounter something even more fundamental. The spacecraft stops accelerating. Narration. The speed of light is not simply a difficult speed for our engines to achieve. Pause. It is built into the structure of special relativity. Display: C equals 299,792,458 meters per second. The equation appears cleanly. No unnecessary graphics. Narration: for an object with mass, the closer it gets to the speed of light, the more energy is required to accelerate it further. Show a scientific graph rising sharply as the speed approaches the speed of light. The spacecraft engines continue firing. The spacecraft approaches 99.9%, then 99.99%, then 99.999%, still below the speed of light. Narration: reaching the speed of light would require an amount of energy that becomes infinite in the relativistic limit. The graph rises dramatically. Do not display an incorrect claim that 99.9% requires infinite energy. Instead, show the energy requirement becoming increasingly enormous as the spacecraft approaches the speed of light. Narration: at exactly light speed, a massive object cannot be accelerated to that speed. The spacecraft remains below the limit. Narration: this is not simply a problem we solve by building a bigger engine. Pause. It is a limit built into the equations. The equation E equals greater than mc squared appears subtly in space. The equation slowly fades. Narration: that does not mean interstellar travel is impossible. Pause. It means that reaching light speed itself is not available to ordinary objects with mass. The spacecraft moves away. The camera follows it. Then the scene transitions to two clocks. One clock remains on Earth. The other is inside the spacecraft. Both clocks begin together. The spacecraft accelerates to extremely high speed. The traveler's clock appears slower relative to the Earth frame. Narration: then something even stranger happens. The traveler looks back toward Earth. Narration: relativity changes our experience of time. Split the screen. On one side, the traveler. On the other, Earth. The traveler remains relatively young. On Earth, years pass. Cities change. Buildings are replaced. People age. Generations pass. Narration: at sufficiently high speeds, less proper time can pass for the traveler than for people who stayed behind. The traveler continues through space. Narration: in principle, a fast traveler could cross enormous distances while experiencing less time than someone waiting on Earth. Pause. But there is a price. The spacecraft returns. Earth appears dramatically changed. The traveler steps onto the surface. The world looks unfamiliar. Narration: the people you left behind would continue aging. The traveler looks around. Narration: relativity can help a traveler move into humanity's future. Pause. But it cannot simply erase the distance between civilizations. The scene fades into the expanding universe. The cosmic web appears. Galaxies are distributed across enormous scales. The camera slowly observes the large-scale expansion of space. Narration: and then we reach another fundamental limit. A distant galaxy appears. Another. The distances between very distant galaxies increase. Show a scientific grid expanding. Galaxies remain embedded in the expanding structure. Narration: space itself is expanding. The grid stretches. Narration: for sufficiently distant galaxies, cosmic expansion can make the distance between us grow so rapidly that light emitted by them today may never reach us. Do not show galaxies simply flying through space faster than light. Show the expansion of space itself. Narration: this is one reason cosmologists distinguish between what we can observe and what we may ever be able to reach or communicate with. The observable universe appears as a sphere surrounding Earth. The sphere should be a visual representation, not a literal physical shell. Display: observable universe approximately 92 billion light-years across. Narration: the observable universe is roughly 92 billion light-years across. Pause. But observable does not mean that this is the entire universe. The camera moves beyond the visual boundary, darkness. Narration: we do not know the full size of the universe. Pause. It could be vastly larger. Pause. It could even be infinite. Do not show a claim that the universe beyond the observable region has been directly seen. Do not show a mathematical proof of what lies beyond the observable universe. Keep the scene mysterious. Narration: What lies beyond our observable region is one of the great unknowns of cosmology. The camera returns to the observable universe. A distant galaxy slowly fades from the visualization. Narration. Cosmic horizons create a profound limit. A beam of light leaves a distant galaxy. It travels through expanding space. The distance between the source and Earth continues changing. The beam becomes weaker. The scene demonstrates the difficulty of information reaching us from sufficiently distant regions. Narration. There are regions of the universe from which information may never reach us. Pause. And there may be places we could never reach, even if we waited an extraordinarily long time. The cosmic web becomes quieter. Some distant galaxies become inaccessible to our future view. Narration. Over unimaginable timescales, accelerated expansion can leave distant galaxies beyond our future reach. Transition to the local group, show the Milky Way, show Andromeda, show smaller satellite galaxies. Narration. Our local gravitational neighborhood is different. The Milky Way and Andromeda move toward each other in a scientifically plausible visualization. Narration. The Milky Way and Andromeda are expected to merge in the distant future. The galaxies interact. Stars remain extremely separated. Do not show stars crashing into each other. Narration. Gravity can hold some structures together even while the universe expands on the largest scales. The camera moves away from the local group, the larger universe returns. Narration. So is this really a cosmic prison? Pause. Not literally. The visual wall disappears. Narration. There are no known physical bars surrounding every civilization. Pause. There is no proven cosmic cage. Pause. The prison is a metaphor. The universe appears again. Narration. A metaphor for the combination of distance, relativity, cosmic expansion, energy requirements, and time that can make communication between civilizations extraordinarily difficult. The camera moves through the Milky Way. The scene becomes more sophisticated and scientific. Show black holes, quantum fields, space-time diagrams, mathematical equations. Narration. Leonard Susskind has spent decades studying some of the deepest questions in theoretical physics. Show subtle text references to string theory, quantum field theory, quantum cosmology, black holes, the holographic principle. Narration. His work has helped shape our understanding of fundamental physics, including ideas about black holes and the holographic principle. Show a black hole. The event horizon appears. Information is represented through a subtle scientific visualization. Do not turn the scene into fantasy. Narration. But we should be precise. Pause. Susskind did not prove that every civilization in the universe is trapped in a cosmic prison. Pause. That is the story we are using to explore what the laws of physics might mean for civilizations trying to cross cosmic distances. The camera slowly pulls away from the black hole. The universe returns. Thousands of distant planets appear. One by one, faint lights appear on some of them. Narration. Now imagine something extraordinary. More planets appear. Narration. Imagine that life is not rare. More lights appear. Narration. Imagine that intelligence has appeared thousands, perhaps millions of times. Do not present this as established fact. The word imagine should carry the scene. Narration. Imagine civilizations that began millions of years before us. Show advanced but scientifically plausible structures around distant stars. Do not show magical technology. Do not show impossible spacecraft. Use subtle evidence of advanced engineering. Narration. Imagine technology so advanced that we would barely recognize it. Pause. And yet, all civilizations become isolated points of light. The distances between them become visible. Narration. None of that guarantees that they can meet. The camera moves from one civilization to another. The second civilization remains impossibly far away. Narration. They could exist at the same time. Another civilization appears. They could be intelligent, another appears, they could even know that other civilizations exist. Pause. And still never exchange a message. Silence. The lights remain separated. The camera slowly returns to Earth. Earth at night. City lights glow across the continents. A person stands outside looking toward the stars. Narration. So perhaps the deepest question is not simply pause. Where is everybody? The camera moves upward. The atmosphere disappears. The person becomes tiny. The earth becomes visible. Narration, perhaps the question is pause. What if they are there? A distant civilization appears. Then another. Then another. Narration, what if the universe is full of intelligence? Pause. But distance and cosmic evolution keep civilizations separated? The camera shows multiple civilizations across the cosmic web. Each civilization is represented by a subtle point of light. No aliens, no flying saucers, no exaggerated technology, only distant worlds. Narration. The possibility is difficult to prove. Pause. But it is also difficult to ignore. The camera moves toward Earth. A transparent sphere surrounds the observable universe. The sphere represents the observable region. It is not a physical wall. Narration, this sphere is not a wall. Pause. It is a boundary of what information has been able to reach us. The camera slowly pulls backward. The sphere becomes smaller. The cosmic web fills the frame. Narration, and beyond it, pause. Darkness. Narration, we do not know. Long pause. That uncertainty is the point. The music becomes softer. Transition to sunrise on Earth. Warm golden light. A child lies in a field. The child looks upward. The Milky Way stretches across the sky. The child reaches toward the stars. No fear, no sadness, only wonder. Narration. Perhaps this is what makes our situation so extraordinary. The camera rises slowly. The child becomes smaller. The field becomes smaller. The landscape becomes smaller. Earth begins to appear from above. Narration. We may never cross every distance. The Earth becomes a tiny blue point. Narration, we may never visit every world. The solar system appears. Narration, we may never know what lies beyond every cosmic horizon. The Milky Way appears. Narration, but we can still ask the questions. The camera travels through the Milky Way. Narration, we can measure the stars, show astronomers observing the sky, show radio telescopes, show observatories under dark skies, show scientific instruments. Narration, study the planets, show a distant exoplanet, show atmospheric spectroscopy. Narration, decode the light, show light passing through a spectrograph. Narration, build theories, show scientists working with mathematical models. Narration, test them, show scientific observations and data. Narration, and slowly understand the universe that surrounds us. The cosmic web appears. Narration, that may be the most remarkable thing of all. Pause. The universe is unimaginably large. The camera moves farther away. Millions of galaxies appear. Narration, and somehow a small species on one small planet learned to look at it and understand some of its rules. Silence. The camera continues moving outward. Earth becomes almost invisible. The entire observable universe fills the frame. Millions of galaxies, billions of stars, countless worlds, no music, only a faint atmospheric sound. Text appears slowly. Maybe we are not alone. Fade. Maybe the universe is full of life. Fade. Maybe some civilizations are far older than ours. Fade. But none of that guarantees that we will ever meet. Long pause. Earth appears again, very small, the camera holds. Narration, because sometimes. The greatest barrier between civilizations is not the absence of life. Pause. It is the universe itself. Black screen, complete silence. Then one final line appears slowly. The cosmos may be full of voices. Pause. We just may not be able to hear them. Fade to black. Hold the darkness for several seconds. Then show a subtle view of the Milky Way. The camera slowly moves toward the center of the galaxy. Stars fill the frame. The music returns very softly. Narration. Perhaps somewhere on a world we will never reach. Another civilization is looking upward too. Show a distant planet. A night sky. A subtle artificial light. Narration. Perhaps they are asking the same question. Pause. Are we alone? The camera moves away from that planet. Return to the cosmic web. Narration. Perhaps the answer is already out there. Pause. Perhaps we simply cannot reach it. The cosmic web fills the frame. Narration. And perhaps that is the real mystery. Pause. Not whether the universe contains other minds. Pause. But whether the universe allows those minds to ever find one another. The final shot shows Earth as a tiny blue point surrounded by the enormous darkness of space. Hold. No text, no explanation, no additional claim, only Earth. The stars and silence fade completely to black.